It's funded by the German Finance Ministry and Bundesbank, the central bank, and we research and connect this research and concerns with the financial community and political central banking community in Frankfurt. And so, I've got a lot of vested interest, not only in the subject, because that's what I teach and research, but also through the institution that I'm associated with, and just connecting these materials and insights. And part of my long story, when I came to Germany, before that I studied literature and languages. So I'm come from a different background and angle, which means, I went through all of the trials and difficulties that you might have gone through. I remember when I first started my master's program, and all of a sudden there was a lot of math. And before that, I'd just been doing just languages and literature, and all of a sudden, I was up every night until midnight practicing maths and doing the calculations. So I remember that, and I'll never forget that. It was a lot of work, and so I'm sure you're doing a lot of work, and it's, be proud of yourself that you're putting the work in, and it'll pay out eventually. I would have never thought when I was starting my master's that I would be here doing this as a professor, right? So, you don't all have to become professors. I don't know if that's what you want to do. So we've got the advanced topics in monetary economics and modeling financial markets in macroeconomics. Like this is the title of this class is just enormous. All right, so my motivation, I'm excited to be here with you, and I hope you are too. I've got welcome, willkommen. It's really hard to do this in latex. How would you pronounce it? Ciao Mung?
Yeah.
Okay, kind of. All right, so I've learned German. The Germans can't tell that I'm not German when I speak German. I've got a long ways to go before I can tackle language like Vietnamese. I'm learning Japanese, which is already just yeah. Anyway, so let's learn and have fun. Like that's the whole idea here. So what do I want to look at? I think the motivation for the way I think you should think about economics and monetary economics and financial markets. The way we're going to look at it is we don't have one solution to fit everything. We don't have like the perfect mastery things. There's not a settled conclusion. Here, right, I know 9.8 meters per second squared is the rate of acceleration. It's done. We figured this out. We understand how gravity works. There's only one model for that. Right? So we don't have that when we think about financial markets and the macroeconomy. It's not just the one model, the one way of understanding things. So what we want to do is we want to learn a suite of models, different models, and these models, they sharpen our mind by narrowing it. So we want to have different models that ignore different things. So in some sense, we want to learn models that we know are wrong. Why is this useful? Well, let me show you, one of my favorite models. So this is a model of the world, Google Maps. Right? You might have this model or something similar. I'm zooming in, and I don't see the track that I went running on this morning. This model is wrong. It's missing details. It doesn't show that, why in the world is this? It's useful precisely because it's wrong. This view here only shows us the streets, right? Or you can select it so that it only shows the public transportation. The subway I heard of is open now in Ho Chi Minh City. This weekend when I go there, I can't wait to ride the subway because I've seen right? You can select this that highlights the roads or highlights public transportation, right? But it narrows. It's ignoring the trees. It's ignoring the track around here. So it's wrong, but that's what makes it useful. We can select a different model the satellite view, right? And now I can zoom in and I can see the running track that was on this morning. It's a different model, right? It's also wrong, right? This is a picture taken a while ago. I could probably find something right here that has been built or hasn't been built, right? It's also wrong. So we have a suite of different models from Google, for example, that we find very useful for moving around places. And each model sharpens our focus on a particular topic, walking, maybe taking, riding a scooter, or whatever, by narrowing it, by ignoring, by blocking certain things out. And the reason why that's so useful is that it alerts you to look for certain items. Here are the streets. Here are the bus routes or the subway. Right? And so the reason why you want to have these different models is that when we read contemporaries, we hear things being discussed on the news, we swipe through and we have a topic on social media, we want to be able to, there's lots of diverse things going on, we want to be able to impose order, to say, well, wait a second, what are they saying? In what context, which model should I apply this to, right? Which Google map is going to show me the roads to understanding what these people are saying. And then I can start thinking about perhaps whether it's right or wrong, or what the limitations are of what they're saying. So we have this suite of macroeconomic theories, suite of financial markets, this selection of models, of ways of thinking about the world, just like with Google Maps. So that's what I want to do with you, is I want to go through and give you a bunch of models. Now, some of these models you've probably seen before. You've probably gone through ISLM before. So my favorite example of why this is very useful, have you done an econometrics course? Right? OLS, have you done OLS?
Yes.
So I remember when I did my bachelor's, I studied linguistics and literature, but I had a minor in economics, and I had to do econometrics. And then I did my master's, and in econometrics we learned ordinary least squares. Then I went to my master's program in economics, and I had to do econometrics, and we learned ordinary least squares. I was in a PhD program, I did econometrics, and what was the first thing we went through? Ordinary least squares. So why are they teaching me the same thing over and over again? Well, every time it was at a different level. The first time I learned OLS, it was, sum of squared deviations, and it was, learning about, there's lots of sums, over the sample size of quadratic terms, and then we divide and multiply xi's and yi's, and, kind of mechanically I saw what's going on. By the time I got to my PhD program, we were using the Frisch-Wald-Lovell theorem to define this as projection matrices projecting onto orthogonal spaces. Oh my goodness, there's no way that would have made sense to me as a bachelor's student, right? But because I'd learned this from different perspectives, right, by the time I got to be a PhD student, I think I finally understood OLS, right? So ISLM, we're going to revisit this, and I think, if I were to ask, right, that's sort of a fair question. We have a chancellor in Germany, a president in my home country. There's leaders of your countries. What economic model, right? If I were to ask them to understand one macroeconomic model, which model would be useful? Which model would I hope that they would understand? Right? In ISLM, if our macroeconomic leaders took ISLM, that would be useful. Why? Well, one, that gives them some good intuition about these way things connect. And two, then we, as economic experts, can talk to them. We go, they understand ISLM, I can try and cast this complicated topic into ISLM. I can bring it to this particular model, right? They understand Google Maps, right? I'm going to explain, this route, this path we're going to take, in the logic of Google Maps, right? So we want to do that. We want to do OLS. We want to see, this intuition, and then I'm going to, there's going to be some points here that I highlight, and I'm going to slowly back down. We're going to find, when we open the economy, if we look at Mundell Fleming of the ISLM, there'll be some conclusions that are different. Just like when we have the interaction of goods markets and financial markets, we'll have different conclusions than if we just look at the goods market. So we're going to see as we move to different models, we can relate them all in terms of perhaps their predictions of a government expenditure multiplier. That's the one thing we're going to look at. And we're going to unify these models or tie these models together by understanding how their predictions for this differ and why. All right. Then we want to look at micro foundation. In these first two models, these very, they're older models. A lot of the behavioral relationships aren't going to be micro founded. Right? We'll see that perhaps consumption here is given as a function of income, but it's not justified as why. So consumption is positively related to income. So as people's income goes up, they consume more. I don't know, I buy it. I guess that makes sense intuitively. The reason why this is then dangerous is that if government changes its policy, perhaps the manner in which people's consumption responds to income might change. But in these models, we can't address that possibility because we assume a static relationship. Right? And so if we want to take seriously the fact that people will see what we're doing, will understand slowly or quickly, but eventually they'll figure it out and change their behavior, we need to do something called micro foundations. We want to model our private agents, households, and businesses as doing the best they can, as optimizing. Right? As a household, we'll think of them as having some utility function, and they're going to be choosing their savings, their consumption, to maximize their well-being, their happiness. And firms will be choosing how much to produce or what prices to set to maximize their profits. And we'll see how this relates to consumption savings for households, and then we'll relate this to how we can price assets. And we're going to find there's some fundamental relationships between these two things, something called the pricing kernel, or the Lucas asset pricing equation. It's going to allow us understanding how households make the consumption savings decisions is going to reveal their preferences that will allow us to price any asset in the economy. So fantastic, amazing, powerful theory. And then we'll look at some data and we'll see, I don't know. This isn't quite the 9.8 meters per second squared. There are going to be limitations to this. So that's something we want to keep our mind open. Then we're going to take these building blocks and we're going to essentially build an ILSM model that uses micro foundations. That's the baseline, that's the new Keynesian model. Right? And then we'll look at an open economy version of it, and we'll look at an asset pricing version of this. Now, the reason why this is so important is 90% of the macroeconomic models used at central banks, at research institutions, at universities worldwide, have at their core this model. Now there's a million ways that this can, have been, and should be extended, right, that we won't get into. Right? We're going to do a couple extensions here. Right? You can think about, well, now maybe we could look at distributional effects. We could look at we're going to look at a small open economy. Maybe we should look at a model of multi-countries, like in the EU, they have lots of different countries. How do they interact? How do we have an open economy model if we're a smaller opening exporting economy that's interacting with maybe two larger economies? So a model of Vietnam with China and the United States. That might be very useful, particularly now when we see some of the political economic choices that my country's president is engaging in, right? And then how Xi Jinping is responding to that, right? Very, very useful, but this can all be done, has been done, or will and should be done, right? So hopefully, at the end of this course, you will be equipped with the tools in terms of the modeling, that is at the background of every model that's at the forefront of research today. Now, we can also do this, so last year I got the feedbacks. There's a feedback and review of the course where I get graded, right? I take that very seriously. Like I try, this is really important for me. And I got the feedback last year that they wanted to do some more hands-on work with the computer, with MATLAB and the models that we have here to do that more interactively. So you can thank last year's students that we're going to spend some time doing that. Right? I think it's, it's good, but so it's kind of, on the one hand, I guess that's more. Oh, more work. But on the other hand, it's not something that I'm going to test you on. So think of this, as like, this is an important, and it's useful if you want to write a thesis with me or with Michael Binda or anyone else in the macro region. If you know how to use MATLAB and know how to use Dynair, and you've learned these models, you're going to be ready to go. And I had a master's student from a cohort 2 years ago who, in her thesis, looked at New Keynesian model and had the model adapted to data of Vietnam, and that was a fantastic thesis. Right? There's so many things that you can do. I mean, you also have a very distinct advantage in that there's not a lot of this modeling that has been applied to example for Vietnam. Right? Well, that's kind of a shame, right? But then it's fantastic for you because you have a better ability to access the data. When I look at the website of the Vietnamese Statistical Agency, it's very difficult for me to figure out which data is the right data. Just right there, like I'm lost. I can't win that battle, right? So you have a distinct advantage and probably an inherent motivation to understand perhaps what the consequences might be for your whole country if you look at different policies from these models. Okay. All right. So what's the objective? What's the objective of macroeconomics in general? Well, right, we want to understand the aggregate facts, the macroeconomic facts as they are, and then try to understand ways of explaining these facts consistently. Right? So, this marker is heavier than this cloth, right? We can understand the first, wow, they hit the floor at the same time. They have different weights. The fact seems to be that the rate of acceleration by gravity is independent of the mass of the object, right? That's a fact, right? A physics fact, all right? Let's understand that fact. And now I just tried to explain it, right? Gravity acts on bodies independent of their mass. There's 9.8 meters per second squared. There's no times weight of object or times mass of object there. So first understanding, and then way of consistently explaining this fact. And then you've gone further, that's not true, actually. Right? Why? This marker is exerting a gravitational force on the Earth. Right? So the larger the mass is of an object, it's actually going to pull on the Earth. Right now, this is so small that there's no way we can ever measure it, right? I might be a little bit bigger, so if I fall, I'm exerting gravity in the Earth. I mean, that's still not big enough, right? But at some point in time, we can then see that maybe we can observe different facts and understand that there is perhaps nuances, maybe a different model. Right? If we're looking at markers and towels, 9.8 meters per second squared is fine. If we're looking at the interaction of the moon and the Earth, right? Or better yet, the orbit of the planets around the sun, right? Why do we have an elliptical orbit? Right? We don't orbit the sun in a circle. Why not? Well, if you think about it, Jupiter is really, really large. The sun is even larger, but Jupiter is also exerting gravitation on the sun. So it's pulling the sun around with it, which means we're orbiting around the sun that itself is moving, and this is giving us this sort of eccentricity in our orbit, right? Giving us this, contributing to the non-perfectly circular orbit. Okay, wow. So, different facts that we observe, we start to explain, develop theories, and can you tell that economics is you've got a inferiority complex, what we call it in English, right? We really wish we were physicists or natural scientists, right? And we try to approach a lot of what we do with that mentality, though, right? Which is, that part of it is useful, the scientific method, right? Let's observe, right? Propose a theory and test the theory with the observations, right? Apply the scientific method, right? And this is so very important to keep with this. Right? Why? Because economics and economic topics in politics is so often not scientific. I have my way of thinking, and that's the right way, right? And it's the right way because I think it's the right way. That's not very scientific. And we've had a lot more success in, say, natural sciences in having the data interact with theory to come to conclusions to tell us what to do. Why, for me as an American, it's scary to see what's going on in my country with vaccinations and medicine. We're now forgetting, dismissing, throwing away science because some people have political beliefs that they think are more important than the scientific facts. Right? We don't want to do that. We want to try and apply the scientific method. Right? That's find the facts as they are, and then try to explain these facts. That's what we want to do. We don't want to impose our beliefs on these facts. Right? We don't want to adjust the facts to match our thinking. Right, so again, another reason why we want to do this mathematical approach, right? It's not just because we love the physicists and mathematicians and chemists and biologists and all the natural sciences, but right, the mathematics provides a rigor of argument that cannot be achieved in other social sciences yet. Right? Which is why they're doing this. Why? If I lay things out mathematically, you start from my assumptions. Right? You can check whether my conclusions are correct. Right? They're verifiable. Right? And the math is the math. So, okay, we start with assumptions. That's the right conclusion. But what assumptions do we need to be? We need to hold for this to hold true. We can then examine whether these assumptions fit the facts as they are. So it's also falsifiable. Right? So we want to come up with theories that are verifiable and falsifiable. And if we do it mathematically, right, there's a consistency there. It doesn't matter how good my rhetoric is, right? How good of a salesperson I am, how flashy, razzle-dazzle, explaining and convincing. The math is the math. Anyone can do the math, right, if you know the mathematical techniques. Right? There's some people, I'm probably not the best politician, I'm probably not the best salesperson, because I can't convince people this, but I can do the math. Right? The math doesn't care how big my smile is, right? Or how small my voice is. It doesn't care. Right? And this lays bare the linkages between assumptions and conclusions, right? So that we can't hide anything behind our rhetoric. Right, and this way of thinking is very, very old. We don't have the 9.8 meters per second squared. We can go back to John Maynard Keynes, 1922. Right? We don't have a body of settled conclusions. Right? It's a method rather than a doctrine. So we want to start developing, or continue, you're not starting obviously in master's students, right? A way of thinking, right? Techniques, a suite of models. Right, so what is a model? Right? Edward Prescott said it's a compact way of presenting a theory, necessarily an abstraction, so it's wrong. Right? It's a measuring device for how well the theory can match, explain, or predict economic data. Right? We can. There's a model here. there's the supermarket that I went to yesterday. Right, so it says it's 3.2 kilometers, and we can walk there in 45 minutes. That's a prediction, right? We could test. We could see, did it correctly predict the distance and then the time it takes to walk there? So what does this device do? It relates different points spatially, and with its model of what the routes, the sidewalks, the streets that connect these 2 points, that model, right, gives a prediction that tries to tell you how long from A to B. Again, the Google Maps is the exact way that I want you to think of economic models. Right? It's an abstraction, right? We're going to be, but it's going to be designed for a purpose, just like the Street View and Google. And it's something that we can, match, look, observe, and correct and fix. That's why events like the COVID, the coronavirus, horrible event for humanity, right? I don't want to go back. I don't know if I've kind of forgotten what it was like. I don't want to think about that. But for economics, it was fantastic. Why? It gave us data. It was a truly exogenous event. It was a natural experiment. What happens if, for reasons that aren't endogenous to the economy, we shut down our economies for 3 months, and we're going to let different countries respond with different policies? That's an amazing experiment that generated a lot of data. You could say the same thing or something similar is going on now. There's one person who, for reasons we don't want to explain, is imposing all sorts of different tariffs on different countries that make no sense economically, right? This is going to generate a lot of data. We will at very least understand the open economy in a couple years better than we do now, because we're going to see what the effects are of all these different economic policies of the president of my country. All right, the physics, so Thomas Sargent also liked this physics connection. You think back to Richard Feynman, one of the best physicists. So if you're bored tonight, what I would suggest you do, just to see something amazing, watch on find Richard Feynman there's YouTube videos of the lectures in physics that he gave in the 1950s. Right, so you can, it's old black and white footage, and this Richard Feynman, so 75 years ago, is in a lecture hall explaining physics, and it is humbling how engaging this person is, right? Just in terms of I can sit there and like I'm bored and like he's talking about physics, and I'm just fascinated, right? I can't turn it off. And what he said about physics was that it's like trying to learn the rules of a board game like chess by watching 2 people play. Right? So, there are 2 people playing, and you see, one person moves one piece, and then the other person moves one piece. They alternate, and each turn, each person moves one piece. We're learning the rules just by watching people play. And that's also a literal description of what economic scientists should do. We watch the economy, we try to learn the rules of the game. If this happens, what's the consequence? Again, that's why things like COVID or the Trump policies are, in some sense, useful because we're seeing something perhaps we've never seen before. This is going to allow us to learn rules of the game that we might not have known before. And sometimes also the rules of the game change midstream. Right? So, imagine if suddenly gravity changed, and it was like that can't. Hopefully, that can't happen with physics, but it happens with economics frequently. Right? The rules of the game change. Right? Why do the rules of the game change? Because the rules are based on interactions between us, people. And as we change, right, the way in which we interact changes. The rules change, right, when we change. And also sometimes when we learn the rules, we change the way we behave, which changes the rules that we've learned, right? There's a feedback effect there, right? That does happen in physics. Has anyone thought of quantum physics? We've learned, quantum physics, this subatomic particles, they've, we now have quantum computing, so this is, the topic of the future. So they figured out that when they observed that finding the location of some of these subatomic particles was described by like a probability function, but whenever they tested to measure it, wherever they looked for the particle, they found it. Exactly what they were looking for. Why? The act of measuring changed the interaction. And that's what we like to understand with economics. We have some of that flavor of quantum physics, that our engaging the economy, our setting policies, our interacting changes these rules. Right? So we want to detect and understand these changes, right? And sometimes also recommend changes in the rules ourselves. Right? So we have to detect patterns, but it's not enough for policymakers to detect patterns. Right? We need to know what will happen under interventions that change rules in unprecedented ways. This is difficult, this is a problem. Why? Well, in physics, that's not okay, that's not such a big problem, right? If I want to understand whether these three objects fall at different rates, we can conduct an experiment. Right? Those two at the same speed, those two at the same speed. I'm conducting an experiment, that's fine, fantastic, and they're all falling at the same rate. Now let's do the same experiment here in Vietnam. What would be the consequence if the government doubled the tax rate? Which province are we going to run the experiment on? Right? Should we double the tax rate in Ho Chi Minh City, right, and see what happens so that the rest of the country can learn from that? No. Let's not do that in Ho Chi Minh City. Right? Let's choose Hanoi. Yes, let's double the tax rate. And what are people in Hanoi going to say? No. Wait a second. Do you realize the problem here? We can't conduct experiments in macroeconomics the same way we can in physics. We can conduct experiments in microeconomics. We could get volunteers, right, to participate. If we're going to play a game, and we'll give you money based on who wins the game, and we're going to learn about your individual decision-making process. Why? It's voluntary. You can opt in. We can run that experiment. But macroeconomically, you can't. It's inconceivable. We could ask everyone in Ho Chi Minh City. It's also this year we're now in Ho Chi Minh City. I thought that was right. We're no longer, was it Binh Duong? Yeah. Ho Chi Minh City got bigger, right? We could ask everyone for their consent. We're going to learn about the economy in Vietnam. Do you voluntarily agree to let your taxes be doubled? Right? And if we asked everyone, everyone said yes, then maybe we could run this experiment. Not going to happen. And just imposing it is probably not ethical. Macroeconomic experiments are not possible. So how do we even begin to think about helping our governments, for example, understand the consequences of their policies? We can't run the experiments like we can in physics. The best thing, the closest thing we can do is theory, to build models. And then in the model, within the theory, double the tax rate. This is going to make predictions, and we'll use this to inform policy. And that's why having different models, because none of our models are perfect, right? Looking at the predictions of different models and using this to inform policy is essential when we try to help policymakers understand the consequences of their actions. Right? We don't have the luxury of being able to conduct experiments quite the way as other people can. Right, okay, so what do? We observe, we detect patterns. Right? So we see people's income goes up, consumption goes up. Right? this looks like, so there's a positive correlation between consumption and income, right? But it's not causal. For example, I've noticed that when I come to Vietnam during the monsoon, the rainy season, I see lots of people with umbrellas, right? Do you agree? Right? Yeah. So I think, you know, the rain, there's too much rain here. I'm sorry. I'd like less rain. So my idea, let's outlaw umbrellas, because rain and umbrellas go together. So if we get rid of the umbrellas, there'll be no more rain, right? Well, no, that's obviously wrong. I have causality in the wrong direction here. We all know that it's the rain causing people to carry umbrellas, not the other way around. But in many cases in the data, it's not clear. Are we consuming more because we have more income? Or do we have more income because we're all buying more things, generating more income to the people who own shops and restaurants and cafes? Which is causing what? It's not quite so clear, which is why we need to build a theory. The theory, that's the whole point of these models, a structural model, is to give us a consistent, hopefully, if it's a good model, consistent way of giving a causal direction. And the parameter, this might be the correlation between consumption and income, and this might be the marginal propensity to consume. That tells us the direction goes from income to consumption. Now, if we look back in history, these two parameters are going to be related. This marginal propensity to consume is something that we can measure directly from the correlation. Right? And then we might want to predict, right? So if history continues, if behavioral patterns continue as they have, and we just have more income, right? We get lucky and find money lying on the street, how do we predict our consumption will change? Or we can look at alternative regimes. If we change the structure of the economy, right? If we change tax rates, right? If we change the tax rate on consumption, right? A value-added tax in Europe, or a sales tax in the United States. Well, if taxes on consumption change, then for a given income, the amount that you consume is likely to change, which means this historical parameter, this correlation will likely change, right? And we can now predict the consequences because we're going to be changing this theoretical parameter that we understand that we control. So we can make a prediction under an alternative regime with different taxes, i.e. what happens if we double taxes without having to pick on a particular province here in Vietnam as the experiment. All right, so this model then in the end is then, Thomas Sargent, he likes to talk really mathematically. It's just a probability distribution, and the model generates specific correlations, specific pattern in the moments. Right? It's a statistical model that's controlled by some parameters. Right? Which again, this is important. None of our models, if they're honest, are going to tell us if we increase taxes by 100%, if we double taxes, then income will change by exactly this much. No, it's a statistical model. It's going to give us maybe, we think that income is likely to change by between this and that much. Right? It's going to give us sort of a probability distribution. It might be the most likely outcome, but there's no certainty. These are all, if these are honest, these models, they're statistical. And on top of that, we have different models. Right? So our predictions, if anyone gives you an exact prediction of the future, I'd be very skeptical. If they don't have the ability, the understanding, the honesty, the reflection and introspection to tell you we're not certain, it looks like most of the data or the models are predicting movements in this range, okay. Right? It needs to be a little bit more nuanced and not this, I'm going to do this a lot, I've got to, we're the greatest country, China's been treating us very, very badly, right? You just hear this, man, and it's just, the certainty that Donald Trump proclaims in his understanding of the world is very suspicious to me as a scientist. You know, if I was as certain about anything as he seems to be about everything, right? You know, I would be a lot more forceful, perhaps, in some of my predictions. You know? Statistical model, right? There's uncertainty. All right, so you know, why this New Keynesian framework? Well, Dr. Milton Friedman, Nobel laureate a long time ago, said we're all Keynesians now in the 1960s, and now many today would argue that we're all New Keynesians now. Right? So that's going to be our understanding of business cycles. We're going to go to the New Keynesian model. We're going to start by first going into the ISLM. All right, so that's my yeehaw, happy, welcome introduction. So I guess, you know, now, did you have any questions sort of about the I guess, motivation and structure, what to expect, or anything like that? I mean, questions come up later, like, you know, interrupt me at any time. But like, now's kind of the time, like, you know, so we have put the schedule together. You know, one thing to keep in mind. So last year I did everything on 4 days, so Monday through Thursday, and now I'm going to add in Friday mornings. You know, so we'll have to. I mean, I don't know. I know that how many of you take the bus or the shuttle from Ho Chi Minh City? I mean, there are some people here. Great, yes. So I mean, so I know that there's some limitations, like, you know, like, okay, so if we're done on Friday at noon, I eat, then, you know, I don't know, you can see, we can talk about if we want to do something afterwards, but I think maybe it's also good, you know, have some time to reflect. Then, we have the lunch break that's scheduled in here. Do you like to take a break in between? Like a short 5 or 10 minute break during the 3 hours? I think that's probably a good idea. Yeah? Yeah, okay. Because I love this and I have so much fun. I could talk about this, you know, these topics for 10 hours without stopping. So I will try to remember to take a break, but please remind me too. Right? If you know, we need to take a break. I can see that Alex, Professor Mangoda, is really exciting and a lot of fun, but we need to take a break. Tell me. Yeah? Please, and don't be shy. Okay. Right. So we're going to do ISLM. So the exercises have you all found the online learning platform? What's it called? Icarus or Ilias? Something like that. I'm sorry. Yes. Yes. Oh, yes, you have. Yeah. So you'll notice I just put up a new version of the first lecture. I changed the content a little bit, but forgot to change the date from last year. So now I've changed the date. But don't worry, the new lecture has nothing new compared to the upload from last week. It's just that I realized I haven't, I changed content but forgot to change the date at the beginning. Yeah, so I will use that. We have the lectures. This camera, it's being recorded, right? The recording. What I recall from previous years is that the camera doesn't have, right, if we write things on the board, what I will do, if I write things or we write things, I will take pictures with my cell phone and upload them every day, all the pictures and stuff, yeah? Just, I think that's then useful. Yeah, so it's not plenty, but because I have this, you know, we have 2 extra half days compared with what I did last year, I want to try and find some time in here to do the computer stuff. So but I wasn't exactly sure what to do. What I mean is, so this is, if you work with cloud, the reason I did this cloud, like Dropbox is a powerful, the Hessen box is from the University of Frankfurt, they have their own sort of cloud Dropbox thing, is that then it tells me when my co-authors are working, right, because it's updating things, and this makes me like feel bad, oh my goodness, they're working on the project and I've not done my part, so then I have to do my part, right? It's a really sort of it's a social motivator. Yeah, but so I wanted to know a little bit about what you've done with computers before, to think about when I can put some stuff in here where we can do computer stuff together. So, have you used MATLAB before? Yes, you've all used MATLAB. And you have MATLAB installed on your computers?
Yeah, but we just had the trial.
You don't have to, because I thought there's a new campus license here, there was a couple of years ago. You just have a trial, or what do you mean by the trial?
We used the trial for one of our posts, and
It's not.
It's expired.
Yeah.
Ah,
I have the rec version, or the version, I think it's fine.
yeah, but, okay, so that's good to know. Okay, so. All right, so I'll have to think about. I'll have to think about that. So, I mean, there's. Yeah. Okay. So the trial version has run out. So there's some, so maybe. Yeah, so I'll think about that, and look at some stuff tonight, and we'll figure that out then. All right, that's why I didn't plan, right? That's why I wanted to ask first, so, that's unfortunate. Yeah. Okay, so, all right, what we're gonna do now, how about we take a little break now, and then, so like 10 minutes, and then we'll start with the first lecture. Yeah?
Yes.
So I'll see you then at 10:05.